Welcome.
Thank you. I think this might work. Let's see if the lavalier works. Yes, it does. Excellent. Well, thank you, Colleen, for the very kind introduction and for being such a wonderful partner for us at the Create Lab to work with at Penn State New Kensington. And thanks also to Chancellor Snyder for creating this conference and having the vision for us to have forged such a tight relationship between Carnegie Mellon and Penn State New Ken. I'm going to try and set the stage. I know I was supposed to end at 12:30, but it's 12:25, so I'm going to give myself a little extra time. We'll go maybe 10 minutes extra. But I'm hoping that my remarks can set the stage for an outstanding panel discussion that really talks to local industry and the ways in which technology can transform the ways in which we think about our future and how we can empower ourselves to make a better future through technology for all. I do have a habit of talking quickly, so I apologize in advance. Just slow the speed down if you want, however you know how to do that. Let me start by explaining the disruption that we're in terms of technology and robotics. If you think about a cartoon model of technology and robotics and what technology and robotics was like even just a decade ago, one way to think about it is that robotics and, in fact, computer science were fragile. They could solve very narrow problems, and when they were challenged with something slightly outside of the design sphere, they broke, they failed. As a result, in the world of robotics, we did things like put chain link fences up in manufacturing plants. And the robot arm was inside the chain link fence, and we were outside. And they didn't even have a motion sensor. So if you went anywhere near the chain link fence and stuck your hand in, the robot shut down, the line shut down. So the fragility was absolutely there. The second part that's really important to understand about early robotics and AI and computer science is that our world was one in which there were silos, separate walls of inquiry and action. So you had digital computing, and digital computing worked in the domain of digital computing on the main processor from IBM. And you had robotics, which maybe included heavy machinery and motor control in a, let's say, a CNC mill. But to a large degree, the robots we had in a mass manufacturing plant, like a Toyota plant or a General Motors plant, and the computing infrastructure we had for digital technologies in an office were completely separate. And because of that, the innovations that happened in one place stayed there. They didn't bleed through. And more to the point, large companies made large investments in any one of these silos to break through and make money. So it was a very large barrier to entry. And that's the world that we lived in. That is not today's world anymore. And I'm just going to give you a few stories of how the world has changed. One of the most important things to note about the world that we have today is what I like to call human-robot interaction. So our robots and our computers interact with us thickly. I mean, you all carry around one with you. And it interacts with you. You can actually ask it to do things for you, and it does them. I was just at a friend's house in Minneapolis this weekend where a newborn came to be. And they had so many times during the day when they asked Echo to do things for them. Like set a timer. Like remind them what the weather's going to be tomorrow. Like send a message to somebody. Their interactions, their social interactions in the home included this digital technology. That was unheard of a decade ago, and that's a major way in which we're changing. At the same time, robotic technologies are enabling machinery around us to sense us and interact directly with us. So not only does that thing have a speaker, and it can hear my spoken voice, just like your phone can now, but in fact, digital ads can look at your face from 10 meters away, and they can tell whether you're looking at the ad. They can tell whether your pupils are dilated, whether you're interested in what they're showing you. They can tell by looking at the changes in the color of your skin at a 60th of a second how fast your heart's beating and whether the ad is exciting your face and making you respond with increased heart rate. And they can turn the gestures of your face, the lip reading, the eye control, all of that into a sense of who you are and how you're responding to that ad. That, again, wasn't possible before, but it means that psychology and psychological analysis is merging with technology. At the same time, on the physical side of robotics, we're seeing massive and fast changes now. You know, we all hear about Moore's Law, the idea that computers are getting faster and faster. But batteries are also improving much more rapidly now in terms of energy density and costs per unit. At the same time, motors are improving. We have no longer science fiction, robots developed at Carnegie Mellon in companies like Heartlander that actually land on the surface of the heart and do heart surgery while your heart is beating. Think about that for a second. It's going interior to your body, just like an interventional neuroradiologist digs into your body and knows the highway system of your veins and arteries. It's landing on your heart and doing heart surgery, and they don't have to stop your heart, which means no heart-lung machine and no bypass system. While your heart is moving up and down, it happens to be on the surface. So as far as it's concerned, nothing's moving. That's a level of motor control, a level of motor action that was unheard of even 5 years ago. And now they're doing clinical trials of that kind of technology. On the cognitive side, we can see the same benefits and advances. So Washington Post, one of the esteemed journalistic outputs of our country. Who writes the sports column for the Washington Post? It's written by a computer. There's no sports journalist writing the Washington Post sports column. It's a computer system that reads all the news feeds and then writes the articles. Another example for you on the cognitive side is law. The biggest companies in DC and New York, if they get a bill from K&L Gates or Morgan Stanley or somebody, and that bill for their law includes time spent by a first-year law clerk doing, say, contract review or patent review, they send it back to the law firm and say, no, we're not paying that. Why are you using a first-year law clerk to do that? Software already does that better than law clerks. In fact, law clerks are having trouble getting their first-year job out of law school now, for real, in this country, precisely because AI systems can do most of their job cheaper. And so law firms use them. So the dynamics, even at those high cognitive levels of a white-collar job, are changing because of technology. And so you see, we've really changed the world we live in around us because of mechanical advances, because of cognitive advances, and because we've broken down barriers between those two and between how robots and we interact with each other. Now, there's 4 key issues I want you to be aware of as we talk today and beyond that this relates to. One of them is actually the overselling of technology. We have a danger in society, which is that we oversell the capabilities of these technologies because they are so cool. They do so much that we jump the gun and decide they can do even more. And as a society, we need to be fluent and understanding of what their limitations are so we can use them right. And that's a real challenge. The obvious, big, charismatic, megaphonic example for you is self-driving cars. You've all heard about it. If you go look at the newspaper archives for the last 5 years, for 4 of those years, every journalist worth their beans was writing, it's just around the corner, within 2 to 3 years we're going to have self-driving cars on the roads. This is amazing, it's going to save so many lives. If you just go do a Google News search now, just in the last 6 months, every article you find in a major magazine or newspaper will say, well, we don't know when self-driving cars are going to come, it could be decades away, it could be 30 years away, but they're really good. And what's happened? What's happened is that the promise of self-driving car hit fully into the reality of the accidents that happened and the difficulty that companies had explaining those accidents. And that gets at the heart of the matter. As a society, we lack technology fluency. We lack the understanding of the boundaries of how technology works. And because of that, we don't have a good internal litmus test for understanding how technology is going to influence our lives. And that's a really important thing that we need to gain. And I'll be talking about that because it relates directly to education, which is a place that Penn State New Kensington can give this area a leading edge. The second main issue I need you to understand has to do with technology, dignity, and privacy. One of the other challenges we face in society is, of course, that the way we work and how we derive identity from our work will necessarily change because of these technologies. That law clerk has to think differently about his job. If you can work at the International Trade Commission, that's a good one. If you can work on problem solving and deep analytic problems, that's great. But contract negotiation, reviewing simple NDAs, no, not so much. That's gone to the domain of artificial intelligence. At the same time, we know that privacy and data are interesting, difficult forces in society today. Cambridge Analytica and the issues at Facebook, as well as the Google Plus news, 52 million people whose information got released yesterday. That's all news. It's news that we don't know how to process. But the important part is that our sensor systems throughout our world collect information. That information has massive monetization potential. And the people who figure out how to monetize it right, they are going to be the winners in that society. So we need our students and our educational systems to support that kind of innovation here. But that innovation has to take into account the right to privacy. It has to create a sense of dignity for the people so that you can monetize data without usurping the authority that people have to be themselves and to build their identity with their own data. Now, Europe has taken major steps in that direction with the general data privacy regulations that they've just instituted. And it's likely that America will have to go in that direction as well. But it's an interesting game because a lot of the surveillance and data is collected globally. The very fact that Europe has created new regulatory behavior has already forced change in America. And so boundaries get crossed that way in a pretty major way. I'll give you one more example from the area of data and dignity that's interesting. Watson, IBM system, has been demonstrated in a number of circumstances to be able to make diagnostic decisions for doctors better than doctors. If you go look at the news stories on this, it's really interesting. Doctors will say, physicians will admit that Watson can read 10,000 articles a week. It's up on modern medical advances better than I am. Of course I want to use Watson. And yet there's also boundary cases where you see doctors not going down a difficult and treacherous path with a chronic condition because Watson provides a glib answer early, and they decide to just believe Watson. So we need that really interesting design interplay where you can use the power of the technology that can read 10,000 articles better than a human, and at the same time preserve enough know-how in the physician so that the physician still knows what to do. Just like in a 737 or a 747, we let the autopilot fly, but we also know when to turn the autopilot off and have the pilots fly. And there's a whole regulatory behavior enforced in the 737 to make sure the pilot's getting enough flying hours to always be proficient when they turn that autopilot off. So that idea of technology and the limits of technology, that's something we need to study. The third one that I want to tell you about is ethics. One of the most powerful things we can do as a society is to start thinking about how we infuse ethical thinking in our engineers. It used to be in computer science and in robotics that I had students who worked on the whiteboard, and then they had cool ideas, they published papers, and then they went to NASA. And maybe they worked on a real robot that pushed on Mars. Today, we have students who work on whiteboards, publish papers, write code, and then go to any of a number of startups around the world or large companies and push back on the real world right here. It's not Mars anymore. They make material changes to how we live on Earth. In medical robotics, in military drone technology and lethal robotics, and of course in educational robotics, cognitive tutors, you name it, manufacturing. Those people are now pushing back on the physical world around us. And yet as a society, we haven't figured out how to instill in our engineers an understanding of the ethics of what they do so that they can have a heart and an imagination that leads them to bend the arc of the future to the best possible world we can live in. And that means thinking emotionally and intellectually, combining an anthropological understanding of the world with their entrepreneurial understanding of how they can make change. That's critical, and that's a life skill we don't teach well. And that's something that I think we know how to innovate, and something that our region, New Kensington and the Pittsburgh region, can be actually global leaders in. So I want to stop by giving you a couple of specific stories about some of the ways that I see exciting future directions. And really, it's all about bridging this digital and physical divide. It's about the fact that robotics and artificial intelligence are going to infuse every kind of job we have. And that means no matter what kind of job you have to understand their limitations and their affordances and how to best parlay them into a useful pro-social tool. But I'm going to give you a fun example. I have to go to education because it's so much fun. What's an example of an educational program that's a home run? And Kevin and the Create Lab has heard me say this story a million times, so apologies, but I'm going to have to say it. Utah borrowed some air quality meters from us for a third grade classroom. And here's what they did. They put them in the third grade classroom that's facing the driveway where all the parents pick up the kids at 3 o'clock from school. And they had the kids get pieces of paper and make a check mark of how many cars idle at 3 o'clock while waiting for their kids to get out of school. So they counted the number of idling cars, and they noticed the air quality getting worse in the classrooms facing the driveway. So they studied biology. They studied fluid dynamics and the idea of how diesel particulates move and how they cause asthma. So they understood the biological implications of idling. Then the kids designed an anti-idling pledge form at school, went home and called family meetings. These are third graders at home calling family meetings. Sat down with their parents and lectured them on air quality and the hazards of idling your car. And then they offered them the pledge form and said, here, we want you to pledge not to idle anymore. So they got their parents to sign pledge forms. Then they went back to school a couple weeks later. They counted the number of idling cars again, and they measured the air quality in the classroom again. And then, I kid you not, a student came in, a college student, and helped them run statistical p-test correlation studies on the statistical correlation between the idling reduction and the air quality improvement. And they got a good outcome. And yes, they won the blue ribbon at the science fair. What's powerful about that example is that you have kids crossing disciplinary boundaries. They're learning about biology. They're learning about these particulates. They're learning how to use a scientific tool. But that's not all. They're inverting hegemonic power relationships. They're learning to go home and challenge their own parents and teach them something new. And then they're learning to measure how they've actually made the world a better place. They're learning how to go to school then and measure change and show that their own actions can enact a change that makes the world a better place. That skill set in 3rd grade, I want every 3rd grader to have. Because then they grow up seeing the relative power they have to make society better through technology's use. And when they come to New Ken, then they can learn the most exotic possible ways in which to use technology, and then they have the firm footing to go on to an educational pathway and an entrepreneurial pathway that actually causes them to make the world a better place. That's sort of the ultimate example that I want to see. Now, I want to end by talking about the hope that we have, but also the challenges we face. I was actually sitting at this lunch table right in front of me, and Debbie Askins and Bill Kabazi were with me at that table. And Debbie runs a health clinic here and reminded me that this area, New Kensington, actually has a massively high free and reduced school lunch program. You have poverty at a massive level here. Now, I work very, very closely in West Virginia. And I want to notice something interesting about that relates also to the other person at my table, Bill Kabazi, who runs an industrial machine shop that actually builds all sorts of bespoke custom tools right here in New Kensington. So he needs people who can use high technology tools. And we, Debbie, the whole community here needs to lift people out of poverty. How do we do that? We do that by creating a relative advantage for the small company. And one of the powerful things about AI, machine learning, data analytics, is that the entry cost for these new technologies is low. So you can have new entrepreneurial startups who use the best new technologies to create a relative advantage over large companies for whom change is hard and slow. And so this is the chance that we have in these areas to lift ourselves out of poverty. The challenge I leave with you with is we have to do it equitably. Because it's so often the case that we can cartoon technology as a tool that exacerbates inequalities in society, that makes capital owners more rich and laborers less rich. The challenge is through small business and through joint ownership that we create a different model for that. So we have a model where the people who work in that small company and a number of small companies actually lift many out of poverty through increased salaries and through increased entrepreneurship through technology innovation. That's the challenge we face. Only through education will we create a pipeline to lead there. Bill was talking about how hard it is for him to hire people today. It's only education that can change that game. But it's education that's right-minded, that combines the left and our right brains together. And that's something I'm really excited about in our partnership through ABC Create with New Kensington. So that's it for my opening remarks, and I welcome the panel up. Thank you.